All right, so we're going to take a look at, we're still in 1.7, and we're looking at composing functions. So this is f composite g of x. And so let's do this problem together. And then after we do the problem, we're going to take a look at what would be the domain. So f composite g of x means f of g of x. And g of x is going to be, is given to us as 1 over x. And so we're going to put that as the input into f. So I'm going to rewrite this as f. And my new input, instead of g of x, I'll put 1 over x. So then I look at the top and I look for function f. It is 4 over an input plus 2. And my input here is 1 over x. Now, this is the composition of the two functions. However, I want to simplify this. We don't usually have a fraction within a fraction. So in order to simplify this, we're going to multiply everything by the denominator of this fraction. So I'm going to multiply this by x, and this by x. And then that will get rid of that denominator. So I will have in the numerator 4x. Here, the x's will divide out, leaving me with 1. So I've gotten rid of that denominator, plus 2x. So this would be the composition of the two functions. Now on the next page, it says, well, find the domain of the composition. So what we're going to look at first is we're going to look at the domain of the input. So the inner function. So what is the domain of this function here? So pause the video and take a look if you could tell me the domain there. All right, now that you've unpaused the video, did you come up with all real numbers except 0? There's an x in the denominator. So since there's an x in the denominator, what I'm going to have to do is set the, so if we have an x in the denominator, you always set the denominator equal to 0 and solve for x. So the denominator here is simply x. Set the denominator to 0. It's already solved, right? So I'm going to draw this on a number line. Actually, let me put it over here. And here's 0. So the domain of function g of x would be everything this way and everything this way. The only thing we need to exclude is 0. So I can either use the parentheses here or the open circle. So far this is what we have. And so I'm just going to write the description. It's all real numbers except 0. Now let's take a look at the composition. So the composition is f composite g. So first you look at the domain of your input. So the domain of this. Then you look at the domain of the composite. And so the domain of the composite, take a look here. Where's our composite? Oh, we didn't write it here. So let's write it over here. The composite function has a domain, it would look like this. And our domain, to find that, set the denominator equal to 0 and solve for x. So I'm going to subtract 1 from both sides. I get -1. And then I'm going to divide both sides by 2 to get x by itself. So I get -1/2. So the domain of this would be all real numbers except -1/2. So I'm going to draw that now on the number line. And so let's do that one. Remember, we're looking at the composite. We didn't, and notice how we did not do the domain of f, because we want to know the inner function, and then after you compose them, we're concerned about that, not of the outer function. So now let's, if I was to write that on my number line, so here's 1, here's -1, here's +1, -1/2 would be here. So just to give myself a number line here, and then I'm going to say it would be everything but -1/2. So it's going to go this way and this way. So what we're interested in is the overlap. Where are both true? Where will both work? And it's the overlap, so it's the intersection. It's that symbol that looked like this, the intersection. So where do they both work? Here, let me highlight it in yellow. They both work here. They both work in between -1 and 0. And then they both work to the right of 0. Let me see if I can highlight this without it. So I've got 3 pieces to represent an interval notation. So where I highlighted in yellow. And so to the left of -1/2 would be from -infinity to -1/2, not including -1/2. So you notice I don't put a bracket there. In between -1/2 and 0, and then 0 to +infinity. And that's the union of all 3 of those pieces. This would be the domain of the composite function written in interval notation. And then the last thing in this section is expressing h of x as a composition of 2 functions. So this is saying this is the composition of 2 functions. What were the original? So it would be like working backwards. So if you were given this, what are these 2? So you're working backwards. So when you see these type of problems, like this one, you have, so I want to know what 2 functions did I have to compose to make this h of x? So I want to know what was f of x and what was g of x. So I was going to look at these and I look, is there an operation here? Well, we've got the operation of addition and we've got this radical sign. So if this was my inner function, this expression, if that was this part, if I was inputting this into the square root, then I could get h of x. So my outside would be the square root of x. So if I put this into, input it into f, I end up with the composition. So my original functions would have to be the square root of x And then the g of x would be x squared plus 5. What if you had, let's give it some different names here. Let's say we have p of x is equal to 1 over x plus 4. And we want to know, let's make this separate here. We want to know what two functions, so what two functions, when composed, would give you p of x. So I see the operation of division here, and I say, well, this expression here, I look for the expression kind of, could be inputted into 1 over something. So my middle function could be x plus 4, and my outer function could be 1 over that something. So in place of the something, what I'm circling is where I put the plain x, and that's my outside function.